Okay, so here, there's three sections to this exploit development. There's command injection, which is where you can the data that comes from a user is misinterpreted as code and executed as code. There are many situations in which this happens. We already saw this with prompt injection in AIs, and this is the earlier version of it. And then we'll do binary exploits where you inject data, which is then executed as machine code. And then we'll do the same thing for Windows. And we got some more fancy things to come after that later. Although I'll probably, after the command injection, I'll probably do Rust. But let's do so the first thing is you need a Linux virtual machine. And it's best to have an Intel-based virtual machine. You don't actually need that for all the projects, but for when we get to the assembly language, most of these assume you're getting Intel assembly language. So I would use UTM and run a Debian machine here. That's how I did it. And you'll find this as part of the instructions in the first project here, setting up a Linux virtual machine. And if you go here, it talks about various if you're using a PC, then you have an Intel processor and you can just download and run a pre-made Linux machine. If you have a Mac running on Apple Silicon, then you use this product called UTM to emulate the processor instead of using VMware, which would just pass through the real processor to the virtual processor. This UTM product emulates emulates an Intel processor. So if I go in here and do uname, well, first let me connect with SSH, which is the best way to do it. Let's see if I already have that connected. Looks like I do. Okay. If I do clear, all right, make this bigger. All right, so if I do uname -a, it tells me I'm running on, this one's running on ARM64. Well, all right, that's disturbing. All right, I'm going to have to work on fixing that. Let me get to my UTM, and let's see if it's this one, uname -a. This is the AMD. Okay, I'm just connected to the wrong machine. I must have left my VMware machine running, which I thought I had turned off. Let's just power it off here with sudo power off. All right. All right. And now this one here, if I do IPA, this one here is running on 192.168.64.4. So I can do SSH Debian. Oops, not listening to me. At 192.168.64.4. And I know that's right because this thing likes to run in the 64 subnet, but I spelled the number wrong, 192. There we are, Debian. All right. Now clear. Now uname -a. Okay, now I have an AMD processor, Linux. So it's an emulated processor. My hardware is actually ARM, but this is acting as AMD, and that's what I want for these projects we're going to do. So now if you don't know your Linux command line, I imagine a lot of you do, there are a couple projects here you get to practice them. Probably the most fun is Linux Journey. If you haven't seen this, this is really good for beginning students. You go here and it has nice lessons, section by section, with like a little textbook kind of thing to read, and then a quiz for each of these chapters, teaching you all the basic commands like PWD and CD and history and all that good stuff. So this is all really very good. You can, my students really like this. So the beginners really like going through Linux Journey, get them started. But anyway, if you do know your Linux command line, then we can move on to command injection. And so here, this is a really common flaw in router configuration pages and many other places where you have an IP page that takes an IP address, like to test your networking. And when you send pings, what it does is it obviously is just running the command line ping command. And you can see the code that's doing this. Right here is the PHP code I use to do this. This is the way lousy programmers write. You don't figure out how to accomplish your goal in one language. Instead, you mix two languages together. So I make a command line, ping minus C2 space, and then I take data from the user, and then I execute it with system. And this is very dangerous, and this is how you create command injection vulnerabilities, because I can just put a semicolon and then say ID here, and it will do the ping and then execute the ID command, telling me who I am, and you can do anything you want by just adding it here in this line, like ls ifconfig, that sort of thing. So here it is doing an ls listing the files, and here it is running ifconfig, and so on. So this is quite common that if you code in this extremely dangerous manner, then input from the user gets executed as commands on the system. That's the simplest form of command injection. And a more fun one is one that affected all the Linux machines, and this was one along with SSL Heartbleed that convinced the world that Linux is not more secure than Windows. Back before about 2014, this was a very common belief that Linux is intrinsically more secure than Windows. And then there were some spectacular security disasters that applied only to Linux to demonstrate that that's not really true. So here, if I find an image to use, let's go here, for example, and find the image that goes with this conference and save it, say on my downloads. I'll put it on my desktop. All right. So I've got this JPEG image. Now, the ImageMagick is a library that's used in a lot of Linux machines to uh, process images. So here, I'm using it to process the image and to create a thumbnail. So it creates a 300 by 300 thumbnail and puts the thumbnail version here. And you'll see this software used in a bunch of Linux-based bulletin boards and social networks and such. And I echoed out the commands that I executed here. So it converts the thumbnail. Now, the vulnerability here is you can make a text document. Let me open up a text file in my text editor here. All right. And what you can do is you can make a file that looks like an image, but it actually includes text. So this text goes in here, and I just save that on, say, my desktop as exploit.png. You give it a file. Now, the point of this is, well, let me upload it and then we'll talk about it. So if you process that file, and what does this say? Show all. Oh, there we are. Now I can go to desktop, exploit, okay, and upload that image. Now it executes this command, and here you see hello and the date. So if you take a look here, here's the hello and the date. So what happened here is the developers of this image processing library decided it's not enough to just process real images like JPEGs and PNGs. We're going to make it possible to add extra commands inside the image file, text, which will define something like a background color. And then they decide it's not enough to just put the background color in the text. You're allowed to load the background color from a URL. So they have this fill command that'll fill from a URL. And the way it implemented it was by taking this URL and adding it after a curl command in the command line, just like I did with ping. So with appropriate punctuation marks, you can add extra command line commands here. And so you can execute arbitrary commands. So there's a bunch of flags defined now that you can eject things. You could make a file that did an ls, for example, here instead. If I save this with an ls, and then I upload that file, now here's the ls. Here's the series of files in this directory. And so some of those files contain flags and hints and stuff. So there's some flags defined here. So that's a fun one. And here's another one, even more fun to play with. Drupal is an open source alternative to WordPress. Not as popular, but a lot of people use it, and it has had a whole series of really catastrophic injection vulnerabilities called Drupalgeddon and Drupalgeddon 2, and I think there's even a Drupalgeddon 3. So here I'm running a Drupal website with the default flaws, and I put it behind a simple login of student one and student one, like I mentioned in earlier classes, because otherwise automated exploits will hack this thing within an hour or two. But this student one login is enough to block the automated exploits. Student one. I got to type it better. All right. There we are. We get in and we see a default website that has no content, but it's there. And so to exploit this vulnerability, you need a Python script. And this is it. That Python script will exploit it. So let me put this in some system. Let's see, I don't need this anymore. I could use this Linux box. That would be fine. Let's put it in a directory just so I don't make a mess. Let's make dir 127. And I guess I can put it right here, drew.py. All right. And I think this is now compatible. All right. Now, I don't like the colors. I think they're hard to see. Let me do minus W. Is it W none? I think it is, or else it's Z none. It must be Y none. There we are. That gets rid of the colors. All right. And so what's going on here is it's going to connect to this. It's going to log in with the username and password. Here they are, basic authentication, student one. And the vulnerability here was in something called the user registration. There was a field you could inject code into, and here's the injected code. Echo smiling face into yourname.txt. And instead of using a greater than sign to output redirect, it uses pipe T because certain characters don't work. And this is very common with command injection. You need to add certain punctuation marks to get to the place where you can inject the command, and then certain characters don't go through. So what this is going to do is create a file called yourname.txt. Now, one thing about it is you can only make each file once and you can't modify it. So every time you run it, you have to modify this file name. So I'm going to make it 121, and it appears 3 places. So my more organized students will just make a variable and update it, but I'm too lazy to do that. I just update it 3 times. So this will make a 121 file if it works. Python, Drew. We'll see if it works. All right. It thinks it did, and if it did, it will have taken a smiley face and put it in this location. So let's try that. And it did. It put a smiling face in that file. Okay, so now you can execute arbitrary commands on the box. And so what you do is first you have to update the name of that file, which is here. Let's make it 122. All right, now I can execute other commands other than that smiley face. So I'm going to take echo this jazz and replace it with, say, ls minus l to get a list of files on the box. So I save this file, and then I run it again. Now it tells me to go to 122.txt, so I can just change that up here. And there you go, a long list of all the files on the box. And as I mentioned before, these boxes are virtual servers running in DigitalOcean, and they run for a long time, like a whole semester or two, with all my students hacking it. So it gets all full of junk as students create all kinds of files in here. But that's the point. And so there are some flags hidden on here, and you have to inject commands with this technique. So this gives people practice with basic command injection. That's the simple kind of command injection. And another thing, of course, you're probably familiar with is SQL injection. And I was glad to get a sort of organized set of challenges here. I used to be a database administrator, so I'm used to this. And I made a series of MySQL databases to play with here. And I realized the real problem with students is they don't understand SQL in the first place. So being able to inject into this strange language is not as helpful as it would be. So this is where you just get the kind of interface that a database administrator gets, where you can execute arbitrary commands. So you can show the databases, and you'll see there is one called information schema and one called widgets. This is really important. The information schema is automatically generated and always has the same structure. And the other databases contain company data. This doesn't. And you can look in the information schema to learn the structure of the company data files to get into them, which is very helpful. So I can show tables. see what tables are available, and I'll see that that it uses the default database, which is widgets, and shows me there's an employees table in widgets. All right, and we'll get to there. So you can select various strings and substrings and combine them. Now, one thing I could do in this interface is I can just find everything from the employees table by doing select star, and it has ID, name, and social security number for people. So that's nice, but under normal SQL injection situations, you can't use this star because you don't know how many columns it brings down, and you have to carefully control the number of columns. So you more likely have to refer to a specific field, like say just ID and then 2. So this will fetch ID from the table, and the second entry will always be 2. You can put a constant here to select just a constant number. And so then the question is, how do you find the names of the fields? And that you do this way. You select the table names from information schema tables, where there's the automatically generated place where the table names always go. And now you get a whole bunch of capitalized tables that contain automatically generated information. And at the bottom, typically in lowercase, you get the tables that contain company data. And after you have tables, you can then get the columns from a table here by getting column names for the particular table you want. So this is how I would get the names of the columns. Now I find that the employees table contains ID, name, and SSN. And now I can get anything I want. Now that I know how to ask for it, I can select things like this, like we did. I can select ID from employee and employees S, need an S on the end. All right, and I can select ID, comma SSN, and then you get that sort of information. And if I need to put it in one field, I can select concat of ID. Let's put a delimiter in, a space, and then SSN. And that will just get the same information, but it will all be in one column. One. So that's what you can do. But of course, a hacker does not have access to this window where you can execute arbitrary commands. What they have is they have this kind of thing. Let me just reset the server. All right, they have a place where you can search for names. So I can search for, say, Bill Gates and submit, and it'll tell me there is someone named Bill Gates. If I search for someone that doesn't exist, like X, it will give me no result because there is no user named X. But the vulnerability is you put in an apostrophe, and it will show me the query. This will select name from employees where name equals X apostrophe. And the problem with this, just like all the others, is it takes user data and puts it in a SQL command where it can be misunderstood as commands. So the extra apostrophe causes a syntax error, which you see here. And when you see the syntax error, that means you have a command injection vulnerability because you should not be able to enter any data which will break a command. It should either succeed or fail, but it shouldn't cause an error unless it's misinterpreting part of your command as something that came from the administrator, which is what's happening here. So now you can give it a more careful injection like this one. And this one, I gave it this name. And so the apostrophe here terminates it. Then this is commands or 1 equals 1. And the pound is a comment to eat up the last apostrophe to avoid a syntax error. So now I can get all the data out of there. And that's the problem. And now, even more importantly, I can do this one. This one is the heart of it all. Now you can add two tables together. I can do the query looking for a name called Sam, and then I can union another query as long as it has the same number of columns. So there's nobody named Sam. The first query completes. The second query runs and selects 1. Now, that means I can now do any of these things up here. For example, if I wanted to get the column names, I could take this whole column name query and I could put it here as the second query in that long, messy thing. And now I'll get all the column names. So what's happened here, because of this SQL injection vulnerability, I'm able to turn this box that only accepts a name into this box that selects an arbitrary query. I can put in any select query I want to, like the way the administrator can. So now I can do all those things and I can pump things out. Now, professional pen testers don't usually do it by hand like this. They use the product SQL Map, which is very powerful, and I have a few challenges where you can practice using SQL Map. But probably the most fun part is blind SQL injection. So I'll reset the server again because, like I say, like all my projects, this is running one database and many students are hacking it, changing it all the time. So now here's another place where I can search for a name. So I can search for Bill Gates and it finds Bill Gates. Okay. If I search for somebody that's not there, like X, then it gives me no result. So far, it looks the same as the previous one. But now, if I use one of these injections, like this one, um, where I'm going to hopefully get a whole database to dump, it's going to tell me X or A found. What's happening here is it's running the query and it is subject to a SQL injection, but when it's done, it does not show you any data from the database. Instead, it echoes the data you put in. So what I can do is I can have this injection where I'm looking for a name that doesn't exist, or I'm doing a comparison here. So if this condition is true, I get an answer. If that condition is false, I'll make it A equals B. Then I get no answer. So now I can ask yes or no questions. So if I want to get the length of the database name, I can execute this, and we'll see if the length of the database is 1, and it's not 1. So if I change it to, say, greater than 1, now it's true. So you can answer one yes or no question here. You can play the game 20 questions where, but yes or no questions, you learn things, and you can even pump out an alphabetical number. So you can go to this one, for example. This will select a name from employees where name equals Bill Gates, and the first character in the name is a B, which of course it is. So I can submit that, and that's true. But if I had to make the first letter an A, that would be false. And I can see I got no result. And you can use the queries up above, find out, you can get to the password and get the first letter of the password and then see, is it A? Now you could do 26 A, B, C, D, but you can also do this. You can use greater than or less than for letters too, and they work in alphabetical order. So if the name is not A, it's probably greater than A, and that's true. So you can pretty quickly zero in on anything. You'll be able to actually dump out passwords and everything with enough queries there. So those are the classic injection things. Um, and here's one where you write your own program that has a command injection vulnerability. Um, uh, that's just, this one here is where I do it in MS-DOS, pardon me. So you can attack an Windows machine the same way. And I have down here it is. This is a PowerShell script running on a Windows server that is going to do a directory. And I think it might be a MS-DOS script, I forget. But anyway, the point is you can now show the contents of a directory here. So I can put dot, and it's going to give me the contents of the current working directory, which runs down here. And it's doing this by executing the dir command and then taking input from the user, just like these others. So you can add another command here, like dot and who am I? And in this case, you'll see that you are the administrator, which is why this server gets trashed by my students very frequently. I'm glad to see it's still up from last semester. So now you can now execute arbitrary MS-DOS commands here, Windows command line commands, and therefore you can figure out how to do a directory, figure out how to search for files, figure out how to dump the contents of files and get them somewhere you can see them. And so I have some flags defined on this server with Windows command injection, which I must say my students have a lot of trouble with because many of my students are not very proficient at the Windows command line. Anyway, so those are the classic injections. And there's one more worth mentioning here, which is entertaining and mind bending. I learned about this from Twitter years ago before I left Twitter. Um, People said, I just developed a new SSTI, and here it is. And there was a whole line of code that looked like a complicated SQL injection, and I didn't know what that was. But this attacks modern web pages. Modern web pages are not static HTML pages like mine. They are running scripts on the server to generate the page that you see, and they're written in a template language. So if you go here and look at one of my servers, you see one of these template generated pages. And you can search for users here, like I can search for, say, Sam. And when I search, it will always find Sam. It doesn't have a real database. It just thinks that every user exists. So that's not very exciting. What's interesting is you can inject into that page. And here's what you do. Try this injection. Double curly braces and then mathematics in the middle. And let me see, I can put this in another window to make it easier to go back and forth. There we are. All right. So if I put that in and search, it finds 4. So it evaluated the math 2 times 2. And so this is how it works. The curly braces indicate a calculated field that should be calculated, and it's letting data from the user be processed by the engine. So this is once again command injection, but now it's in this strange language called server-side templates instead of SQL or command line. So now you can fingerprint the server. This is how you can determine which popular command processor is running at the other end. So first you do this one, dollars single curly braces, 7 times 7, close the curly brace. All right, you see if that one works or not. And that one did not get processed. It didn't calculate 7 times 7, so I followed the red arrow. Right, so now I use double curly braces. And that one does get calculated, so I follow the green arrow. Now I try to multiply a text 7 times 7. So I add that in, apostrophes around this 7. And that does get calculated. It multiplies the string by 7. So I follow the true arrow, and I'll find out what I've got here is Jinja 2. So that's the particular online processor that's being used. So now what can you do with this crazy language of template injection? And the answer is you can totally take over the box. But the process to do so is pretty entertaining, and it's based on the language Python. Let me just have an open command prompt to get to my Mac directly here. All right. So make this bigger. All right. If you just use immediate mode Python, you can see how this works. Python, and this is because of Python 3 being an object-oriented language. So I can now define a string. All right. And if I do a directory of what methods are available for a string, you can do many things with a string in Python. These are all methods you can do. So you can have like upper. You can do s.upper, and that will be the uppercase, and you could do s.lower, and many other things you can do with it. But what we're going to do here is do s dot and use this one. The underscores are ones not normally used by end users, but by internal processes, but you can use them. I can go to the class, and that will tell me the class of this object is class string. So that's not very surprising, but that's what it is. So now we can walk up the hierarchy. We can do the S class, and we can find out what's the class of that. I need a dot, though, instead of a slash. There. That is type. All right. And I can also do S class base. And that's an object. And this means I have walked up the hierarchy from a string, which is something a user can typically put in. I can add these modifiers to a string and walk up to the root of the entire object tree of Python. So now I started with a string. I walked up here to the object, and now I'm at the root of the tree, so I can now come down and execute anything in the Python language from here, all by just injecting a string. So I can now go to subclasses. Um, And I can do this. This will print out all available classes. And you see there are an awful lot of them. So I can save that in a list object called C and look at the length of it. And there's 198 subclasses on my Mac OS. Different versions of Python have a different number of them. So now I can list the function names. I'll just list the first 185. I'm missing a few at the end, but it doesn't matter. So here's the name of them. Now the question is one of these subclasses useful? And it turns out catch warnings is the one that has the ability to import libraries. So if I find the one that contains the word warning, I didn't find it, but maybe I'm going to have to put in the full number. Now, the full number was 198. So let's try that. Yep, so number 188 is the one I need, catch warnings. So now I can enumerate the built-in methods. I need x equals c sub 188 on my machine. All right, and now I can do this stuff. I can look at the built-in modules for that object. And I'm not sure it's working. Well, I think it did work. Here's how I control these modules. Another long blob of results. So I can now define B of that, do the length of B, and see what those are. All right, so there are 153 of them on my box and class dictionary. So I'm going to find import there, and then you'll see how all this turns into total exploitation of the box. All right, so I have found there is an import in there. And so now I can perform execution. This is going to execute the system command date at this point. And it executes the system command date. So within this Python 3 environment, by injecting a string that has a whole bunch of modifiers after the string, I can execute an arbitrary system command and own the box. So it's pretty amazing. And you can do it here in the template injection. You can do hello class and so on this way in this real template injection web page. And you'll get type string exists and so on. So you can actually execute a whole series of commands here. I'm not going to bother doing it live, but you can do it in this website. You can go in here and you can eventually do all the steps here. So I think I might be able to do it all here. See if this works. I think the bottom line might work. This will do the whole thing, but I would have to adjust a couple of these numbers, although they might be right for my web page. I think this one might already have the correct. Remember, we had to do some loops to find the correct numbers here, but I think that thing might do it. And if it works, this will take ls here and put it in a file called temp out, and then it will read the file temp out and print it on the screen. So this should give me a list. Yep, it's giving me a directory of the root system of the box. So just from a field that takes a text string, which is then processed by the engine, I can execute arbitrary bash commands on the box. So there's some flags to find. And anyway, all those are the same vulnerability. Data from the user is misunderstood as executable code. It turns out to happen a lot more often than you might think. And there's another more exotic one down here, a little harder to set up. So that's the first bit of exploit development I wanted to show you. And this is the fundamental flaw that we're going to exploit everywhere, where you send in data and somehow the server misunderstands that data and treats it as executable code and executes it. We're just going to be doing it in different languages. Here we did several languages, the bash command shell, the MS-DOS command shell, the language SQL, and this server-side template injection. Down here, we're going to do it in raw machine code. All right, so that's enough for this one. Let me stop this video.